Hello students, in this video I will complete physics P5 paper 2 table. So you will see how to calculate absolute errors and how to take care of significant figures. So I will complete three past paper tables. So if you have any problem in these questions, then it's the right video for you. But I am suggesting you to take a calculator with you and a ballpoint and writing paper so that you can do with me as well. So let's do question number 1. Over here you can see T, I in microampere and ln I slash microampere. So you have to calculate and record values of ln I in the table, include the absolute uncertainties in ln I. So in paper, it's always written in below the table that in which variable you have to calculate absolute errors. So most of the students do not pay attention over here, and they just, for example, if you have to complete two columns and they don't know in which column I have to include absolute errors. So over here you have to calculate ln I. So that is ln 46. So you have a button calculator where you have this ln, that is natural log, and ln 46 would be, let me do that, ln 46. Over here you can see this is ln and that is 46. So the answer is 3.8286. But the rule of significant figures over here is, in case of log, the significant figures in a number, they are, you can see they are 2, should be equal to the decimal places in the log. So over here in 46 you can see there are 2 significant figures and you have to include 2 decimal places. So it would be 3.83, that is 3.83 plus minus, you have to include absolute errors. So for example, if you have x is 5.0 plus minus 0.5, what's the maximum value of x? The max value of x is 5.5 and standard value of x is 5. So if you take difference of these two, then you will get delta x, that is x max minus x standard. Okay, so that is 5.5 minus 5.5 minus 5, which is equal to 0.5, that you can see over here. So if you want to calculate absolute error in any value, then you can take its maximum value and you should subtract its standard value from the maximum value. That will give you absolute error in that value. So over here we have to calculate ln delta ln I. So that is delta ln I should be the maximum value of ln I, the max value of this, minus standard value of this. Okay. So what's the maximum value of ln I? If you will increase the number, the value of log will also increase. So the maximum value of I over here is 48. So the maximum value of the log would be ln 48. And the standard value of I is 46. So that is the standard value of ln I should be 46. So you have to take difference of these two, ln 48 ln 48 minus, I'm sorry, ln 46. Okay. So ln 48 minus ln 46 would be minus ln 46. So your answer is 0.04, you can see on the screen. So what is the rule to write the absolute error? If in a number you have two decimal places, then the decimal places in the absolute error should be the same as the decimal places in the number. So you have to write your answer up to two decimal places. So that is 0.04. 0.04. You can see it on the screen on my calculator. So this is how you complete the table in case of log. Okay. So this is the general rule that is applicable for all type of expressions, not only for the log. Okay. So the maximum value of log minus standard value of log, or maximum value of the variable minus standard value of the variable. And the number of decimal places in the log should be equal to the number of significant figures in the number. Okay. So now please stop the video and complete the table. Okay. I hope you have calculated the completed the table with its absolute error. So now you can check the answer from the marking scheme. There, the first value is 3.83 or 3.829. So you can give at least the number of decimal places in a number should be equal to the number of significant figures, or you can increase one significant figure. Okay. So one extra significant figure is always allowed, but I will recommend you to keep the rule simple. The number of decimal places in the log should be equal to the number of significant figures in the number. And in case of absolute uncertainty, the first value in of the error is 0.04. Okay, that is 0.04. So you should take the screenshot, or you should stop the video and you should complete your table and you should compare the answer with this marking scheme. Okay. Now let's move towards the second table. Over here, the values of f, d1, d2 are given in the table. This f is the frequency. You can see it from units. And this 10 to the power 3 is the unit. 10 to the power 3 hertz is the unit. And 1 over f, 10 to the power minus 3 hertz inverse should be your unit. D1, D2 are in centimeter, and you have to calculate and record the values of 1 over f and D, include absolute uncertainties in D. Now you can see you are given two readings of D, D1 and D2, and you have to find D with its absolute uncertainty. So what's the rule? If you are given repeated values, then you have to take their average. The average of these two should be, if you find the middle value, what should be the answer? That is, let me do 24.9 plus the other value is 24.5. divided by 2 will give you an average value that is 24.7. So the central value is 24.7. What should be your absolute error over here? The max value is 24.9. Okay. If you subtract this central value or average value from the maximum value, you will get 0.2. So that is your absolute error. Okay. You can check it. If you add 0.2 in 24.7, you will get 24.9. If you subtract this 0.2 from 24.7, you will get this 24.5. So if you have repeated values for any variable, then this is the way how to calculate absolute errors and how to calculate the value of D. The D value should be the average of these two, and the absolute error should be the maximum value minus the average value. Now again, I will request you to complete this table, okay, by stopping my video. Then how to calculate 1 over f? Over here, what's the value of f? If you can see, f is 1.5 times 10 power 3. So if you will do 1 over f, that would be 1 over 1.5 times 10 power minus 3. Sorry, 3. That would become that over 1.5 times 10 power minus 3. That has been made as a unit of 1 over f. Okay. So you have to do 1 over 1.5. Is that clear? You have to write 1 over 1.5. You cannot write 10 to the power minus 3 over here because that has been made as a unit of this 1 over f. So 1 over 1.5 would be 1 divided by 1.5. So you will get your answer. You can see on my calculator. The rule is simple. The number of significant figure in f should be equal to the number of significant figure in 1 over f. There are two significant figures. The rule of log is different. Okay, but in case of other variables, f 1 over f square, x square, x cube, the number of significant figures should be same. So you have to write 1 over f up to two significant figure, and if you will round this number up to two significant figure, you will get 0.67. Okay, that is 0.67. Or you can write one significant figure extra. As I stated before, you can write this number up to three significant figure as well. So 0.667. 0.667. Okay, so I have completed first row for you. Now it's your responsibility to complete the whole table, and then you should check the answer that I am showing you right now. Over here, you can see if you see this table, the value of, let me make it closer. The value of D is 24.7 plus minus 0.2. You can check it. And the value of F is 0.67, 0.67 or 0.667. So equal number of significant figure or one more is always allowed. Okay. So this has 2 marks. The first mark is related to your, you can see from the marking scheme. First mark is the values of 1 over f and d correct as shown. The second mark is uncertainties in D. So This is how the mark distribution is done. So I hope you have completed the paper table. Let me do one more question. The values of theta and h are given in this table. This is theta, this is h. So you have to calculate v. And what is v? This is the unit 10 to the power minus 5. And what is the v? The value of d is this. Okay. And the volume v is calculated using the relationship. V is pi d square h over 4. So that's the formula. You should use this formula to calculate the value of v. Okay. So the volume is pi d square h divided by 4. Let me write the formula over here. Volume is pi d square h divided by 4. So calculate and record the values of v slash 10 to the power minus 5. And be careful, this should be written in meter cube. Include the absolute uncertainties in v. You can see the value of h is given in millimeter, and the value of d is also given in millimeter. Okay, so let me calculate value of v for first. So the v is pi, d is 27.9 slash 10 time 10 power minus 3, that is in millimeter. So I have to convert it into meter time h, and the value of h is 62.4 time 10 minus 3 over 4. Now, as you have your calculator, so you should complete this, the value of v. So v is, let me calculate that, pi. So that is 20. You can use your calculator from here. So okay, so that is 24.27.9. That is 27.9 time 10 power -3, and bracket -3 bracket close whole square time 62.4 time 10 to the power -3. Okay, multiply by pi. So from where you have to pick your pi. This is my online calculator and I can't see pi over here, but I hope you will have the good calculator with you. So I will put 3.14. Oh, that's good. So I can't see pi over here. Time 3.14 divided by 4. So this is the value of v, and you can see it. The v should be given to how much significant figures? Oh, sorry. You can see from the table, from the given values, the h is in 3 significant figure, and d is also in 3 significant figures. So we should be given to 3 significant figures. Okay. So you can see on my calculator it is 3.81 time 10 to the power minus 5. and 10 to the power minus 5 has already been made as a unit. So you have to write 3.81. 3.81 plus minus. How to calculate error over here? Okay. So the value of V is 3.81 times 10 to the power minus 5. So you have this formula. How to calculate error over here? You can use max minus standard concept, or you can use your AS method to calculate error. Over here you have multiplication case, so fractional error will be added. So delta V over V would be this pi and 4 will have no effect on the fractional error. Okay. So that is 2 times delta D over D. 2 times delta D over D. That is 2 is coming from here plus delta H over H. This is how you calculate your fractional error. So you have to calculate delta V, and at the end, first you will calculate delta V over V, and then you will multiply with V to calculate delta V. So that is 2. Do we need to convert delta D or D in millimeter? In meter, sorry. You know, if you will convert delta D in meter and D in meter, both scaling factor will cancel from numerator and the denominator. So there is no need to convert over here. So put delta D in millimeter, that is 0.1. You know, delta D over D will have no unit. So delta D is 0.1 over D is 27.9 plus H is 0.1 over 62.4. 0.1, no need to convert in meter over here as well. That is 62.4. This is how you will calculate the site. Okay, first you should calculate this and then multiply with the value of V. So delta V will be this whole stuff times V, and you can see this 10 to the power minus 5 has been made as a unit. So this is the unit for reading and absolute error as well. So just multiply with this number 3.81. Okay, I hope you can do that easily, and delta V should be recorded to the 2 decimal places. And please remember, absolute error is always recorded up to the 1 significant figure. So do this, and then I will then compare your answer with the marking scheme. Over here, the answer should be, just do that. My calculator is not favorable, so I am not doing that for you. You can do easily, and then multiply 8.1, then check my answer, compare with my answer. So you can see 3.81, 3.81 or 3.815. 3 significant figure or 1 more is allowed. And the answer is, absolute uncertainty is 0.03. Okay. So 0.03. I hope you can easily complete this table now, and you should feel confident about calculating errors in physics paper 5 question 2. Over here you will be observing that it has only 1 mark. The error has have only 1 mark, but the completion of your whole of the P5 question 2 depends on these errors. If your errors will be incorrect, then your line of best fit, worst acceptable line, everything will be incorrect. Okay. So be careful about calculating the errors, and I recommend you to complete these 3 tables, and then you will be able to perform good in your paper. Okay. Thank you so much. I hope you got everything. See you in next video.